Kimberly Doe is joining us. She's a mechanical engineer and submersible pilot working with Global Sea Dive. She's been running around designing and prototyping robotics for over a decade. Her portfolio includes amazing robots from wearable exoskeletons, humanoid motorcycle riding robots, all the way to several inflatable fabric arms made for NASA. She helps run an underwater robot camp with Erica Bergman for girls 12 to 16. They're hoping to create and mentor a network of strong, empowered women who love to explore their curiosities as well as the ocean and the wild world that we do live in. So I'm going to bring Kimberly in with me right now. Hey, Kimberly, how are you?
Hello. Doing well. How are you? Good morning.
Good. Well, it absolutely is. We're hitting about lunchtime here in the Eastern time zone, but thank you for starting your morning with us in the Women Blaze Trails Festival.
Yeah, it's so great to be here.
All right. Well, you and I connected a little bit earlier in the week because you move around a little bit with the work that you get to do. And we were able to have a little discussion from the Submersible shop. We were able to show us some pretty cool things. So I've got the clip queued up here and ready to go. So if it sounds good, I say we dive into that a little bit and then talk a little bit more about some of the engineering you've done.
Yeah, that sounds great. Let's do it.
All right, here we go.
Hello, everyone. My name is Kimberly Doe, and I am a private submersible pilot. I started as a mechanical engineer with the specifics in robotics, and through a really lovely connection of Erica Bergman, who is a National Geographic submarine pilot, she invited me along board to try being a pilot. And so here I am, and I'm at the Triton Submersibles manufacturing facility, and we'll talk about that in a little bit. But here, Joe, do you want to pull up some pictures and show you what's up? Something that I think is really lovely about this job is that it takes you all around the world in the most beautiful locations ever. This was taken last year in the Bahamas while we were doing a filming shoot for Shark Week, and some of these pictures upcoming are examples of that. It's the most magical. This was right at dawn. The thing that I really, really love about submersibles is that we talk about looking at the surface of the water, like looking at the sky during the daytime, which is gorgeous and beautiful. But then once you go below the surface of the water, it's like you've uncovered a whole new world, and you don't even know what galaxies are around and available for you to see. So yeah, just like epic blue ocean shots. I can never get bored of the sky either, but so these are the two submarines that I dive. The red one is called Nomad, and the yellow one is called Nemo. And they both go down to 1,000 feet and take 2 people, a pilot and a passenger. We usually dive the subs together, which I think is pretty unique for our operation. But here they are at the surface of the ocean. And this is right when she's about to go down. You can kind of see her nose tipping forward. She's about to go diving. This picture over here, so while we were in the Bahamas, this is at around 750 feet. What the sub is looking at are these cute little like whip corals, and they're really, really, really fun and really rare. Something that I think I mentioned earlier about diving 2 subs, you can take pictures of both subs, and so the scale, I think, is like really impressive. When you're underwater, it's really kind of hard to tell how big things are. So seeing another sub is like pretty useful and awe-inspiring in that way. This is a thing we were looking at. I think this is around like 600 feet. We don't really know what it is. It kind of looks like a bunch of novels. I think it's really fun to go running around doing like what kind of human remains have we left down here that have like fallen off of ships, sunken treasures, if you will. Yeah. So we are here at the Triton facility, which is kind of a treat. I'm here right now doing an annual. So that red sub that you saw just got a new paint job. So this is Nemo, and she looks really great. And she's actually quite small. In comparison, we have a couple of other subs. So Nemo only goes down to 1,000 feet. And these two subs behind me are much larger, you can see. And so the subs here, they take 3 people and they go down to 3,000 feet. And then we also have this smaller sub that is super cute. And this one goes down to 1,650, and it takes 3 people. It's pretty awesome because it's very, very small, as opposed to these like kind of ginormous big subs. And then we have our support vehicle. And every time you ever have a submarine that goes underwater, you need to have a support vehicle to make sure there's someone on the surface to watch out for you. So yeah, here we are. These are the submarines. And then I'll give you a little bit of a tour of the submarine. So this is the back of the submarine, and this is our aft fang. So underneath here is kind of like the hood of a car. It's got all of our electronics. Both of our submarines are all battery powered, and this one has lithium batteries, which is pretty cool. These giant blue kind of tanks here are ballast tanks, and so they basically hold buoyancy, which help the sub submerge and then also rise back up to the surface. We'll either fill these with water if we want to go down, or we'll fill them with air when we want to come up. And then I guess let's do a tour of the inside of the sub. Does that sound good, Joe?
Yeah, Kimberly, that's perfect. Let's jump inside.
Okay, so I have a little staircase here, which is kind of dinky. Usually I'll just kind of jump on, but I think this is better. So we'll get up. You'll see here that there is a little staircase ring. So I'll go over here, and this is our hatch. Open up the hatch. And then I'm just gonna hop on in. Okay, so now I'm in the submarine. There's a bubble that exists here. And you can see outside. Woo! So a lot of people think that submarines are really claustrophobic. And I can kind of understand that, but these ones are very, very different because we're in an acrylic sphere. So as soon as you go underwater, the acrylic basically just vanishes, and you don't even notice it at all. I think the most that you'll notice it is kind of right at the surface. We usually have a cover on the surface to make sure that the sun doesn't go through the glass. And so that's the only time you might feel a little bit claustrophobic, but everyone that's ever been worried has been very, very, very excited and completely forgets about the claustrophobia as soon as I get in. So behind me are our air panels. This is our air panel, and this is our oxygen panel. So our air panel is mostly used for what I was calling before is our buoyancy control. And this basically will give us the ability to make sure that our sub is easily controllable in the water and that we're not sinking too far or that we're not just lifting and stuck at the surface. The oxygen panel is for life support. So for us, we just put in a little bit of oxygen the entire time as you're consuming air. And then we have what's called a scrubber down below, which is kind of hard to see. And the scrubber takes out the CO2 that you're breathing. And so that's kind of our air panel. We have some gauges, fake gauges to feel professional. And these are our depth gauges and a barometer. And then you pull down the step stool, and then you have a joystick, just like a game. Over here is your electrical panel. And you can basically use this to sort of turn on our little computer, which is like this cute little tough pad right here. And this will control whether or not you want to use the arm. It'll give you more specific measurements. Like we have, so these are all analog gauges, but we also have digital gauges that will kind of give us a more accurate reading, and it helps us control our thrusters. But yeah, so that's basically mostly it, I think.
All right. Well, Kimberly, let's ask you a few questions while we got you sitting inside of the submersible. The first one being the build time. What's kind of an average build time to get one of these submersibles ready to go?
Oh, by build time, do you mean like from, I guess, Can you ask the question again?
Yeah, of course. So to build one of these submersibles, what's the time commitment like? How long does it take to build one of the submersibles?
Oh, let's see. I feel like if you have all of the parts ready at hand, it probably takes about a week to 2 weeks. I think the problem is that like everything kind of comes in at a trickle. And so the subs themselves, I think, are quite easy to put together and they're quite easy to take apart. We actually have to take them apart once every 3 years entirely to recertify them. But the most of the lead time is just buying parts. Like I think you have to order the acrylic maybe like 6 or 7 months in advance. But if you have a sub ready, then I feel like taking it apart and putting it together can be probably like 2 weeks time, 2 3 weeks. So it's not too bad.
All right. Well, Kimberly, I'm going to bring you back in because I know I asked you a couple questions while you were hanging out in the submersible, but we have you here live. So, I mean, we'd much rather hear from you live. And so you mentioned at the beginning, you know, some people are very worried about being claustrophobic when they jump into a submersible, especially for the first time. But you showed us that amazing acrylic dome that almost seems to disappear once you hit the water. Your first experiences with a submersible, what was that like? Were you kind of nervous? Did you feel that kind of claustrophobia, or did it just kind of melt away once you hit the water?
So I'm a scuba diver. I think like many ocean adventures are, and so I think I kind of sort of got over my claustrophobia sort of when I had goggles on. But the interesting thing is with goggles, you have kind of a little bit of a tunnel vision a little bit just because you don't have your peripherals as much. So it feels like when you're underwater, everything's kind of like, this is the first thing that I'm seeing, and now I see this thing that in front of me, and you kind of have to do this big sweep to see everything. When you go underwater in a submersible, the water just flows underneath you. There's bubbles all over as you're going down, and then it kind of just like opens like a show. You sort of look out, and then you can just like very, very quietly take in what's around you in this very natural way. The submarine seals atmosphere. So when you go down, there's no pressure changes. There's nothing to worry about your body. You're not disoriented. You're not floating anywhere. You don't have to worry about your gauges, your oxygens. You can just go down and be amazed. It's the coolest.
Oh, I can imagine. I mean, as a diver, you are kind of always looking around, trying to take it all in because you're in this amazing 360 environment. But to have that taken away and have that full kind of view, I can only imagine what it's like to have that view when you're underwater. Very cool. So your career, I mean, you've worked on a lot of cool robotics projects, and you sent me a little bit of material here. I want to share a couple pictures because I want to touch on a couple of these projects because, I mean, they look really cool. So I'd love to hear a little bit more about them, and I have a feeling those tuning in would enjoy that as well. So this first one here, this arm, can you tell us a little bit about this project?
Yeah, so robotic arms underwater are known for being giant and electric and heavy and expensive, maybe like $500,000. So this arm is basically almost made entirely out of plastic and fabric. The only thing that's not are the bolts. We were looking into making plastic bolts, but the cool thing about this arm is that because it's only made out of plastic and fabric, it costs about, I don't know, maybe like $600 total in materials. And you can see these bellows kind of where the joints of the arms are. And they're basically just a kind of like an accordion shape. And so the idea is that when you inflate one side of the accordion, it inflates whoosh, and then will push the whole arm one direction. And then when you inflate it the other way, it'll push it the other direction. So inflatable arms are really interesting because for underwater actions and also in space, you don't quite know necessarily how far you are from the thing that you want to grab or do because you're usually not right next to it. And so this depth perception usually means that someone will take an electric arm and then smash it into the ground with a force that the arm doesn't know. You know, the arm's like, oh, I can do this. It smashes into the ground and then breaks itself. With an arm that's inflatable and pressure sensitive, you can get a feel for how hard it's going into the ground and also not break things. But if you do break it, it's very cheap to replace. So this kind of technology is really, really fun. because you can also send it up to space really easily. You can pack it up really, really, really tightly and then inflate it with either air or water. This is one of my favorite projects to work on, and it's also the closest to some of the ocean stuff I'm doing right now. So it's like very meaningful to me.
Yeah, that's so cool. I love the portability of it, the lightweight, when you think of ROVs and breaking apart on an ROV, it's pretty darn scary because those
Yeah.
ROVs can cost millions of dollars. So you break the manipulator arm, and there's probably a lot of panic and worry going on. So having these kind of soft manipulators, replaceable, light, wow, really cool. I can see why you really had a lot of fun working on this project. Now I have a little video clip here, and maybe, I don't think there's any sound, so maybe you can tell us a little bit about what we're looking at in this little clip.
So this is a really cool project that I worked for when I was working on at SRI. So the Taurus Robot is a smaller version of the Da Vinci, which many people, I think, have been operated on because it's one of it's like the surgical robot. And so this is a smaller version of it. And this is kind of something that I think is really interesting because it got me into this idea of telepresence in the first place. And we use these robots they're so much smaller than Da Vinci. This robot is primarily used this time for bomb defusal or disarmament. So this idea that you can send a robot in to go and do a bunch of tasks that a human could, but more safely because your human wouldn't be there. This is particularly interesting because this project, at the time, the Oculus had just come out. And so everyone was trying to figure out in what ways could you try to have 3D manipulators control robots with something that you'd use to play your video game with. We tried to do it actually with the arm that you just showed, the ocean arm, and we put someone on a boat. And, this is a very tough guy. And he has probably been on a boat his entire life, with robots and everything. And we put a little VR headset on him and he gets seasick within seconds. So hopefully in the future we'll fix that. But at the time it was this hilarious large man of the sea being seasick.
All right. Well, there's one more image here from one more project, and this looks so cool. Tell us a little bit about this one.
This is just a glamour shot. I'm just bragging at this point. So this was a project we did with Yamaha, and that we were to make a humanoid robot to challenge Valentino Rossi, who some of you may know is a many world champion for MotoGP. And so this was one of my favorite projects to work on, mostly because it was just a combination of lots of different technologies and then a skeleton around it to basically look like a human. But he looks pretty cool. So this is just like a very fun, when you work on robots, you get to work on a lot of really, really interesting problems. Some of them seemingly more useful than others, but still very, very cool.
Yeah, awesome. Well, there's no denying that you've worked on a wide range of projects, a wide range of robotics, really cool ways to explore and manipulate our environment. And, I was looking on your website not too long ago, you're a hang glider as well, which looks like a ton of fun. How did you get into that?
So it's actually a little bit silly. I'm a little bit of a stubborn person. And at the time, I was complaining to one of my friends about, I'm also a social dancer. I really like swing dancing. And so I was inviting all of my friends out to go swing dancing. And they're like, oh, like maybe someday. And I'm like, they're swing dancing like every day. Like, why don't we want to go? And I was complaining to my friend. I was like, if you don't want to go, you should tell me you shouldn't go. So my roommate at the time was starting to learn how to hang glide. So he was like, Kinley, do you want to learn how to hang glide? And I was like, oh yeah, I'll give it a shot. And he's like, there's a spot on Sunday. And at the time, I really didn't actually want to go very much, but I had just complained to him about how people were like, oh yeah, I'll do this thing, and they never do. And so I was like, okay, I have to do this. And then I went. And the thing about hang gliding in California is that you learn on a little hill first. So you learn on a little 40-foot hill and you run off of it and you just basically glide off the bottom of the floor. And you do that on a really big wing, kind of like a surfboard. And then you slightly go down in size and then you go up in hill. So you go big wing, small wing, and then little hill, big hill. And the feeling I feel like that you get when you lift off the ground is like a very overwhelming feeling, but it's also very a concentrated feeling. And it's this idea for me that I really, really love chasing is that when you're in the zone and when you're concentrated and when you're thinking, there's nothing else that mattered. And that feeling, I think, brings you closer to the current moment in time, which is really impossible, I think, sometimes to find when you're kind of like walking in the world. It's like really hard to get your thoughts of everywhere and the future and the past and everything out. So hang gliding and piloting, I feel like have the same sort of concentration. Like the only thing that really matters is right now, in like a very like tangible way, I think.
Yeah, very cool. So here's the $1 million question. You stepped up and you did the hang gliding. Did your friends then join you for the swing dancing?
No.
Oh, come on.
I know.
All right. Fair enough. All right.
I guess, I mean, I feel like, yeah, maybe jumping off the cliff is easier than hanging out with people.
Yeah, maybe. I mean, some people get very self-conscious when they're dancing. So maybe that's it. Maybe that's the problem. So a question here from YouTube. The subs, the submersibles, who decides where they go next?
So these, the subs that I work for a company called Global Subdive, and Global Subdive owns a very large ship called Go America, or manages a number of ships, one of them being Go America, that has this crane, which is rated to launch the subs. And so when you are like, hey, I have an idea, I have a filming project, I have a research project, I want to just go run around and adventure, you can call our company, Global Subdive, and you're like, hey, I want to go on this adventure. I need you for this many days in this many location. And then they'll be like, we've got you. We've got your support boat. We've got your big, big boat. We've got your submarines and your submarine pilots and your submarine technicians and your surface crew. So it's basically a whole submarine package in this specific instance. So kind of anyone, really.
All right. Really cool. Well, I got to start thinking about ideas and then call you up. That sounds like a good plan. One more question here from YouTube we can squeeze in. And this question is, okay, we saw that larger submersible where 3 people can fit in. So obviously maneuvering the submersible is really important. What else are you doing when you're down there?
So driving a submersible is actually quite easy, and I think everyone should go for it because it's very straightforward. It's slow, and you're always kind of taking into reaction. I think some things that you're worried about oftentimes are current, but the submersibles don't go faster than 2 knots underwater. They're more, I think Erica might have mentioned, they're more like elevators than they are like go-karts. And so if the current is any more than 2 knots, usually we won't dive anyway. But as a pilot, what you're mostly looking for is emergency procedures. So you want to make sure that the amount of air that you have for buoyancy is enough to get you to the surface, even in emergency situations. You want to make sure that the oxygen level in your cabin is appropriate for whoever's in it, and that your CO2 levels are okay, that your battery power is okay. We also are always communicating with the surface. So every 15 minutes, we have a call in with the surface to be like, hey, just so you know, this is where we are, this is our heading, this is how far we've traveled, this is how deep we are. And that way, if anything ever goes wrong, the surface kind of can sort of backtrack where they think we last communicated. And so most of the time as a pilot, what you're really thinking about is kind of just making sure that everything is kind of like check, 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 clear to go. Oftentimes when you're very close to a wall or very close to coral, you want to be just worried that there's nothing to entangle you. A lot of places we go have a lot of drag fishing. So like we want to make sure that there's not a lot of fishing line. But even in those situations where you get a little bit tangled or where something happens, it's very easy just to call the surface and be like, hey, we're coming up. And then it takes from, I think, the bottom of our subs, which is 1,000 feet, about 10 minutes to go straight to the surface. And there's no decompression that you need to worry about or anything like that. So you can just be like, I'm going to go up and just float on up as you ride the bubble up, which is quite nice. It's very fun.
All right, awesome. Well, I'll share this website here if anyone wants to explore globalsubdive.com. Kimberly, if anyone wants to follow along with your adventures, what's the best way to do that?
Oh, I guess I have an Instagram tag, which is, I think Mini Sharkwing is my Instagram tag.
Yeah.
I obviously don't post that much, but sometimes I do, and it's mostly pictures of the sky and the ocean at the same time.
Well, people like both of those things, so you can definitely check that out. Well, look, Kimberly, it was so great to have you join us. What a fun career you've had so far and in engineering as a submersible pilot. And I hope this is the first of many events where we get to explore, share the work that you're doing, and hopefully bring some students along for the ride next time.
I think that's great. If I could just add one thing, Joe, I would really appreciate it.
Go for it.
I just wanted to tell other people out there that it's totally okay if you don't know what you want to do is immediately. I feel like I wandered around for about a decade being like, oh man, I guess I could do this engineering thing before sort of very fruitfully stumbling upon Erica and then building a relationship with her in education before she offered me a position as a pilot in training. And so I feel like a lot of people always ask me how you get into this and how you find yourself in this position. And I think maybe the best thing that I can sort of give people who are looking is just to be flexible and to keep your eyes open and to just continue doing things that you love, even if you don't get paid for them. Not saying that you should only do them, but for example, if you're volunteering or scuba diving, just kind of like do the things that you love and opportunities will come your way. That's it.
That's a tremendous advice. I think, there's no right or wrong way to get into sciences or engineering. Everybody has a different story. Everybody has a different path. Sometimes it starts one way and ends up in a totally different place. So staying open, being curious, trying new things. I mean, there's nothing better. So yeah, absolutely great advice, Emily.
All right. Thank you so much. The women here are so inspiring. Thank you for hosting.
It's been a great weekend. Actually, we're about to switch over to our final 4 hours, our final session of the weekend. So time is just flying by. All these stories I look up and 4 hours is gone. It's crazy. All right. Well, Kinley, thank you so much. Enjoy the rest of your weekend, and hopefully we'll connect again soon.
All right. Have a good one. Bye, everyone.